everyone, I am Shaniba, Assistant Professor in Chemistry, Department of Food Technology. When we woke up in a misty cold day, look around yourself. What can you find in your surroundings? It's nothing else other than fog or mist. Have you ever imagined what are fog? They are neither solids nor liquids. Then, well, they are colloids. Now, let's discuss about colloidal system. Before that, we need to know about the classification of solutions. Solutions are classified into three types. They are true solutions, colloidal solutions and suspension. Now, let's discuss about true solutions. True solutions are homogeneous system in which particles of the solute are of molecular size. Then the diameter range of particle is 0.1 nanometer to 1 nanometer. Then we cannot see this particle using our naked eye or even under a powerful microscope. Then the particles are diffuse rapidly and the particle cannot retain using a filter paper. Then examples: sugar solution, salt solution, etc. Next one is suspension. Suspension is heterogeneous system containing large particles. Then the diameter range of particle is greater than 1000 nanometer. Then the particles are visible using our eyes and also using a microscope. Then it do not show any diffusion. Then the particles settle readily under gravity. Then it can be retained on a filter paper. Then examples are sand in water, barium sulfate solution, etc. Next, colloidal solution. Colloidal solutions are intermediate between true solution and suspension. Then it is heterogeneous system in which dispersed particles are larger than molecular size but not large enough to see under a microscope. Then the diameter range of particle is 1 nanometer to 1000 nanometer. Then it shows very low range of diffusion. Then it do not settle down on standing. Examples: dispersion of starch and ferric hydroxide in water. Moving on colloids, then what are colloids? Colloid is a substance microscopically dispersed throughout another substance. Then these particles pass through a filter paper but do not pass through a semi-permeable membrane. Then it can be made settled on the process of centrifugation. Then colloidal system consists of two phases. They are dispersed phase and dispersion medium. Then what is dispersed phase and what is dispersion medium? Dispersed phase consists of colloidal particles having diameters in range 1 nanometer to 1000 nanometer. Then what is dispersion medium? Dispersion medium consists of a solvent or a medium in which colloidal particles are dispersed. Now let's discuss about classification of colloidal system. The classification of colloidal system are classification based on states of aggregation of two phases and the classification based on affinity between two phases and the classification into macromolecular, multimolecular and associated colloids. First, we are going to discuss about the states of aggregation of two phases. The classification based on states of aggregation of two phases. On the basis of states of aggregation, the colloidal systems are classified into 8 types. They are form, solid form, liquid aerosol, emulsion, gel, solid aerosol, salt and solid salt. Then first one is, if the dispersal phase is gas and dispersion medium is liquid, we can call the colloidal system as foam or froth. The examples are soap, foam, whipped cream, etc. The next one is, if the dispersal phase is gas and the dispersion medium is solid, the colloidal system is solid form. The examples are rubber, cake, bread, etc. Dispersal phase is liquid and dispersion medium is gas, we can call the colloidal system as liquid aerosol. The examples mist, fog, cloud, etc. Next one is dispersal phase and dispersion medium are liquid, we can call the colloidal system as emulsion. The examples are milk, cod liver oil, cream, etc. The next one is dispersal phase is liquid, dispersion medium is solid, The colloidal system is gel. Examples: cheese, boot polish, jellies, etc. Next one, dispersion phase is solid, dispersion medium is gas. The colloidal system is solid aerosol. The examples are smoke, dust storm, etc. The next one, dispersion phase is solid, dispersion medium is liquid. The colloidal system is salt. The examples are starch dispersed in water, paints, etc. The next one, both dispersion phase and dispersion medium is solid. We can call the colloidal system as solid salt. The examples are germs, colored glass, etc. Next one is classification based on affinity between two phases. On the basis of affinity, we can classify the colloids as two. They are lyophilic colloids and lyophobic colloids. Lyophilic salts are that shows a great affinity between dispersed phase and dispersion medium. Then in lyophobic salts, that shows a very little affinity between dispersed phase and dispersion medium. These are the differences between lyophilic salts and lyophobic salts. That shows a great affinity. Then in case of lyophilic, there shows very little affinity between dispersed phase and dispersion medium. Then the lyophilic salts are very stable, but lyophobic salts are very less stable. Then lyophilic salts we can prepare very easily, but in lyophobic salts we need special methods to prepare, and so on. These are the differences between lyophilic salts and lyophobic salts. Next one is classification into macromolecular, multimolecular and associated colloids. First one is macromolecular colloids. As the name implicates, the colloidal dispersion of macromolecular substances are called macromolecular colloids. Then that shows a strong chemical bond between macromolecular particles. And most of the system shows lyophilic behavior. The examples of salts of starch, gelatin, proteins, rubber, etc. Next, multimolecular colloids. The colloidal particles are aggregate of atoms or molecules having diameter less than 1 nanometer, and it shows weak van der Waals force of attraction between particles. And this system generally shows lyophobic behavior. The examples are aqueous sulfur salt, aqueous gold salt, etc. Next one is associated colloids. Then associated colloids are certain substances behave as normal electrolyte at low concentration and shows colloidal properties at high concentration due to the formation of micelles. Such colloidal systems are called associated colloids. Examples: soap and detergents. This is all about classification of colloids. Hope you guys understood. Thank you.